All right, guys, we got another lesson coming at you. We're going to learn how to write the equation of a circle. In order to do that, we have to remember how to find the distance between 2 points. So just a quick recap of how that worked. This is from a long time ago. It's actually the very first lesson we did. If you have 2 points on a graph and you want to know how far apart they are, how did we do that? Well, we drew a right triangle, and we knew that it was x squared plus y squared equaled the distance squared. That's basically what we did. How far across do you go? How far up do you go? That's like your x and your y. So we knew that the distance equaled the square root of your x squared plus your y squared. So this is a process that should be very fast. Getting how far apart two numbers are should not take very long. Like if x equals 2 and x equals 8, you would know that this is 6, right? 2 to 8 is 6. If y equals 7 and then y equals 8, well, then y would equal 1. 7 to 8 is 1. So you're figuring out how far apart your x's are and how far apart your y's are. So let's go practice that a little bit. Highly recommend you practice it without me. But it says find each distance, and I prefer if you try to do this without a calculator. So I'm going to go through all of these. A to B is the first one. A to B, so we look at our x's. 2 to 5 would be plus 3, so we take 3, we square it. Negative 3 to 1 is plus 4, so we take 4, we square it. Don't forget it's the square root. And that's actually a 3, 4, 5. That would be 9 plus 16, which is 25. So that's the square root of 25, which is 5. B to D, same situation. X to X would be plus 15. We square it. 1 to negative 4 would be plus 5. We square it. Wait, I'm doing the wrong one. Sorry. I'm sorry, guys. This is B. It says B to D. Let's backtrack. B to D. B to D would be 5 to negative 3 would be 8. And 1 to 7 would be 6. And that's a triple. 6, 8, 10 would be the hypotenuse. If I was doing this, though, by hand, I would reduce. If you divide by 2, you would have 4 squared plus 3 squared, which is the square root of 25. Don't forget you have to multiply the 2 back in. So it's 2 times 5 is 10. All right, now we're going to do C to D. So C to D would be negative 10 to negative 3 would be 7. We square it. Negative 4 to 7 would be 11. We square it. We take the square root. There's no GCF. There's nothing we can do there. That would be 49 plus 121. So that would just be the square root of 170. That does not break down, so there's nothing else we can do there. All right, A to D. Ooh, all the way downtown. 2 to negative 3 would be 5. We square it. Negative 3 to 7 is 10. We square it. This one I would reduce. That's like doing 1 squared plus 2 squared. That's the square root of 1 plus 4. That would be the square root of 5. But we divided by 5, so it's going to be 5 root 5. Don't forget to multiply the 5 back in. All right, and then B to C. Ooh, I was doing this one earlier on accident. B to C, 5 to negative 10 is 15. We square it. And 1 to negative 4 is 5. We square it. Oh, okay. Yeah, they are slightly different numbers. Just keep in mind, by the way, I've told you guys this before, but when you square a number, the answer is always positive. So do we care if it's minus 10 or minus 5? No. When we square it, it's positive. So I just always get the positive number. I would divide by 5. That would be 3 squared plus 1 squared. Don't forget the 5. And then I would do 9 plus 1 would be 10. So that would be 5 root 10. Perfect. Love it. So that's just practicing distance. You have to remember that. But let's move on to circles. We're going to actually write the equation of a circle. Before we start, let's go back to something you remember. Y equals mx plus b. That's how you write the equation of a line, right? In that equation, what are the constants? What are the things that never change? Those things that never change are the slope and the y-intercept, right? So like if I told you that m equaled 5 and b equaled 7, you would say that the equation is y equals 5x plus 7. Now, what this does for us is it generates some line, right? If I were to graph this, we would start at plus 7, and we would go up 5 over 1, up 5 over 1, and we get every single point on this line, right? I can make x1, x2, x3, x4. Every time I plug in a number for x, I can get the corresponding y value. Those two numbers, x and y, they change. You're never going to plug in a number for x. Like, you're not going to say like y equals 5 times 1 plus 7. You would never leave it like that. That's not the equation of the line. That would produce one location, right? 5 plus 7 is 12, and you would have the coordinate 1, comma 12. That produces one spot. So a lot of people don't understand. This produces every location on the line. You can plug in any x you want and figure out what coordinate it produces. So that's why you leave x and y alone. Those are numbers that change. But the 5 and the 7 you have to plug in. Those are not going to change. Okay, so we're going to do circles now, but I need an equation that would generate every point on this circle, every single spot. How do we make that happen? Well, first, on this example, we're at 0, comma 0, and we have a radius of 5, right? That means if I draw it this direction, it would also be 5. It's 5 in every single direction. So does that sound like a number that changes or doesn't change? Well, it doesn't change. So the radius is a number that's not going to change. It's going to be 5. How about the center? This is 0, comma 0. No matter where I go, is that going to change? No. So the center never changes, the radius never changes, but what happens as we change the x value? We keep getting different y values, and eventually we can generate this entire circle. So we're trying to come up with a formula, like something we would plug into a computer program so that it would generate every point on this circle. And this is what we do, is we pick any random spot. I'm going to pick the spot that they have, and we draw a right triangle. So how could we get this coordinate? If we know that it's a distance of 5, it's basically Pythagorean theorem, but this time we know the distance. How far is it from 0 to x? Like, how far over are we going? Well, that can be kind of hard to think about. So let's change this. What if this was like 4, comma something? I don't even know. 4, comma 3, right? That would be a 3, 4, 5 triangle. So it's right 4 up 3. Right 4 up 3. Right? You start at 0, so isn't that just right 4 and then up 3? Aren't those the two numbers? Don't those produce the radius of 5 that we're looking for? So on this circle, 4, comma 3 is one of the points, but we want every point on the circle. So we're not going to use 4, comma 3, we're going to use x, comma y, and now we can keep changing it. Maybe it's here, so the x would be different. Maybe it's here, x is different. What about here, like x equals 1? Like, the x value keeps changing, but the format doesn't. All of these locations you could drop and draw right triangles. So this equation, if you look here, what would the equation actually look like? It would be x squared plus y squared equals 5 squared, which is x squared plus y squared equals 25, right? That's just Pythagorean theorem, but that generates every spot on the circle. So like if you knew x equals 1, you would have 1 squared plus y squared equals 25. You would have y squared equals 24. So you would know that y equals 2 root 6. So you have the coordinate 1, comma 2 root 6. That is the x, comma y right here. 1, comma, that is 2 root 6. It's not quite 5. And I could do it for every x that I plug in. It would also be negative 2 root 6, by the way. It has a plus and a minus. Okay. But what if you're not at the origin? So this is the real heart of it right here. So don't skip past this. You have to get this. It's the same idea. You draw a right triangle. The radius is locked in. The center is locked in. Now, have you ever seen H and K before? I think most of you have not. Just a real basic idea of what H and K is. I just think of it's the most important spot on the picture. So for a circle, it's the center. If it's a parabola, we call the vertex H, comma K. It is still just an X and a Y, guys. It's just another xy coordinate, but to denote that it's special, right? It's really special, we give it different letters h and k, but they're still just x's and y's technically. So this is at some point h comma k. I'm going to make up a coordinate. Let's say that it's like at 2 comma 3. I don't know where it is, but let's say 2 comma 3. And then let's say that this spot x comma y is at like 4 comma 5. So I'm just making some stuff up, but that's where they are. Oh, let's actually make it 4 comma 6. Okay. So how long is this side? You start at 2, you go to 4, that's plus 2. That's a length of 2. You go to 3 to 6, that's plus 3. That's a length of 3. So how do we get those numbers? Isn't this 2? Isn't that really just 4 minus 2? We took x and we subtracted. How about the 3? Isn't the 3 really 6 minus 3? We did the y minus the y and we subtracted. Here's the thing. Those are not the coordinates. They're x, y, and hk. So how do we get a generic length? It would be x minus h. Whatever those numbers are, we subtract them. This would be y minus k. Whatever those numbers are, we subtract them. And then the hypotenuse is r. So think about Pythagorean theorem here. This would be x minus h squared, that's this side squared, plus y minus k squared, that's this side squared, equals the radius squared. Boom, boom, boom. This is the equation of a circle. Let's go. Perfect. So this is the thing you have to know, and you have to know how to use it. All right, moving forward. What if I told you that you had a shape that has a radius of 10 and a center, the center is at 5 comma negative 2. So the format is x minus h squared, y minus k squared equals the radius squared. We plug in the numbers that never change. The radius is never going to change. The center is never going to change. Will the points x and y change? Yeah. As we keep generating new spots, your x and your y values change. So those stay x and y. So we know it's going to look like this. X and y are unchanged. But what would be x minus h? This is h, this is k. That would be x minus 5. Well, k is negative 2. What's y minus negative 2? That's going to be plus 2 equals the radius squared 100. So this equation would generate a circle with a radius of 10 and a center of 5 comma negative 2. All right, so let's go do today's practice, or not really practice, but like let's practice. Let's practice. The first question is just how long is the radius of the circle? So if I give you the diameter, right? So you have a circle, and I gave you 2 points on the circle, and they say that it's the diameter of the circle. So maybe more like this. So how long is the radius? Well, it'd be half that distance. So distance formula, we talked about this earlier. 5 to 3 would be 2, we square it. Negative 3 to 6 would be 9, we square it. And it would be the square root of that. That would be 4 plus 81, that's the square root of 85. That's the entire diameter. So the radius would be that number divided by 2. So there's the answer to this question. Now, our formula for a circle, remember that it has r squared. What would this number be squared? Because you're going to have to square stuff like this. It would be root 85. If you squared that, the square root would cancel out, and then 2 squared would be 4. So keep in mind, you're going to have to be able to do that. A circle has that center and a point on the circle. So what do we have this time? We have the center, and we have a point on the circle. So wouldn't that distance be the radius already? So the radius equals the square root of negative 6 to 5 would be 11 squared. 5 to 1 would be 4 squared. So the radius is 121 plus 16 would be square root of 137. Write the equation of the circle. So we know the radius. They gave us the center. This is my h and my k. So the answer to this question would be x plus 6 squared y minus 5 squared equals 137. Remember, this is r squared, so r squared would just be 137. That's the number we want to use. As a matter of fact, since we're going to be using r squared so much, I usually don't even simplify the radicals because I know that I'm going to square it anyway. So why would I take the square root just to immediately square it? So that can be a little shortcut. Let's try another one. Here they gave us the equation, and they're asking for the radius in the center. Well, the radius is going to be 7. If r squared, the spot is r squared, is 49, the radius is 7. The center is going to be, we know that this is x minus h, so negative h equals 5. So h equals negative 5. This is y minus k. We know that negative k equals negative 11, so positive k equals positive 11. So there's the radius and center of that circle. And now we're to the fun stuff. I'm going to do 2 of these. I hope that you give it your best shot. There is something that we need to know before we do it. I'm going to show you a little meme. I think we've talked about this meme before, but man, it sure is blurry. Is there a better version of the meme? Let's go see here. Can I get it? Can we get it unblurry? I don't know. It doesn't seem to want to unblurify. Probably not. Okay, doesn't matter. So let's look at this though. This girl, she's so happy. A plus b squared, she thinks is a squared plus b squared. And our little friend's trying to remind her, hey, there's a middle term. Hey, we got to remember the middle term. So let's talk about why we have to do the plus 2ab. So before we do this question, I'm going to go through real fast. If I had like x plus 7 squared, that is x plus 7 times x plus 7. That is first times first, which would be x squared. But then we have outside would be 7x, inside would be 7x. And then last times last would be 7 squared, or 49. We have 2 of these middle terms, and because they're the same numbers, they're the same thing. So that becomes 14x plus 49. So if we look at this, if we call this a and b, this is a squared. This is 2ab, right? Isn't a times b, wouldn't ab equal 7x on this one? So times 2 would be 14x plus, and then this spot is b squared. So yes, you do have the first and last thing squared, but you have to remember that middle term. So that's a big deal. So let's go see what we can do here. These are long problems. They're long. Get buckled in. Be ready. We're going to do the whole thing together. There's a lot of steps. It says find the intersection of a line and a circle. And they gave us both the equations. Let's start with what could this look like? Draw a circle. How many ways can you draw a line and a circle intersecting? Well, the line could hit it twice. 1, 2. It could hit it once. It could be tangent, 1, or it could miss it entirely. So you could have 2 real solutions, 1 real solution, or no real solutions. These are the possible situations for a line and a circle. I'm going to tell you in this class, this is not Algebra 2 or Pre-Calc, I'm talking about right now in my geometry class, we're going to do 2 intersections, and they're going to be whole numbers every time. So if you don't get whole number answers, you did it wrong. If you don't get 2 answers, you did it wrong. That kind of takes some of the work out of it, so it's not going to be as long, but it's still a long question. So what do we do? It's a system of equations. The steps never change, right? A lot of things in algebra, you can memorize steps. I don't like just memorizing steps, but the steps don't change. We need to know where these are equal. Well, they're telling us y equals this. So I'm going to take that and plug it in for y. And what's going to happen when I do that is I'm going to get x minus 5 squared, and y becomes negative 2x plus 6. Let's see what that looks like real quick. Negative 2x plus 6, that's y. Don't forget there's a minus 1 because it's y minus 1. And that's negative 2x plus 5. Please clean it up. Squared, and don't forget it equals 25. Notice that we have to square two things. That's why I talked about it earlier. What does it look like when you square something? It's going to be the first thing squared, two of the middles, and the last thing squared. So on this one, A and B, AB would equal negative 5x. Keeping that in mind, we would have A squared minus 10x plus 25. That's A squared plus 2AB's plus B squared. And then we're going to do the same thing. Let me change that color just real quick. So, oh, I missed one. All right, just so you don't get it as confused. But that's A squared plus 2AB plus B squared. Same idea here. This is A, this is B. AB, if you multiply those, would be negative 10x. So A squared would be 4x squared, positive, minus 20x plus 25 equals 25. Now we combine like terms. So we square both things. We combine like terms. We're going to have 5x squareds minus 30x. And then we have plus 25 plus 25. That's going to be plus 50 equals 25. We want to make one side 0. So subtract 25 from both sides, and this is where we are. And since I told you we're only doing whole number answers, what that means is when you get here, this first number should always be the GCF. It should always be able to be reduced. We divide everything by 5, and we get x squared minus 6x plus 5. If you can't reduce it, you did it wrong. I'm promising you in this class, this is not an always true, but this is true for us this year. It will always be divisible by the leading term. It'll always be 1x squared for these questions in this class. And then we factor, that would be x minus 5, x minus 1. So x equals 5 and x equals 1. But wait, there's more. We're going to have to plug it in. Now, what's easier to plug into, this equation or this equation? And if you said this one, you're correct. So we got to take those numbers, and we're going to have two coordinates. The first coordinate is 5 comma something, and the second coordinate is 1 comma something. X equals 5, x equals 1. Those are the two coordinates. So we plug in 5. What happens when we plug in 5? We get negative 2 times 5 plus 6, and that's negative 4. What happens when we plug in 1? We get negative 2 times 1 plus 6, and that's positive 4. There are my final answers. Those are the intersections for this problem. The line hits the circle twice. These are the two places that they hit. These are coordinates. Can coordinates be negative? Yes. This isn't a length. Remember that negative on a graph is just which direction you go. This is telling me to go right 5, down 4. The distance is still 4. It's just on a graph, it's telling you go down 4. So can a distance be negative? No. Can a coordinate have a negative value? Yes. All right, I'm going to do one more. I would love for you to try it without help. But we're going to do all the steps again. So hit pause and try it. But we're going to take this. We're going to plug it in for y. And that would be x minus 6 plus 3, which is x minus 3 squared. And we still have x minus 4 squared. Don't forget it equals 1. We square it out. That's a squared minus 2ab plus b squared. This would be a squared minus 2ab plus b squared, and it still equals 1. Combine like terms, 2x squared minus 14x plus 25 equals 1. Make it equal to 0. 2x squared minus 14x plus 24 equals 0. We better have a GCF, and we do. Divide everything by 2. X squared minus 7x plus 12 equals 0. And we factor. That's going to be 4 and 3, x minus 4, x minus 3. So x equals 4 and 3. Rewind, watch it, pause it, whatever you got to do. I just went through everything you're going to have to be able to pull off. Now we plug in 4. 4 minus 6 would be negative 2. We plug in 3. 3 minus 6 would be negative 3. And these are pretty close, but makes sense. The radius is 1, so it's not a very big circle. And there's our final answer. So there's some of those to practice on the homework. You know, maybe erase these and try these again. See if you can do it without help. But that's some fun stuff, guys. I'll see you next time.